While the Seagen and East River teams prepare to install their tidal turbines, a third team of engineers joins the mix. But they're not trying to tap the tides. They're out to harness a type of power some think could radically reshape the global energy market: the power of waves.
This is technology which doesn't offer tens or even hundreds of megawatts of power. As we get better at it, as it's deployed, as we get the economies of scale, as the technology is honed and improved, this is technology of gigawatts of power.
The Scottish government sees an opportunity to lead the world in ocean power technology. And Scotland's eastern coast is ground zero for the testing of a determined wave technology program. Proponents say waves carry enough energy to potentially power hundreds of thousands of homes. Now, visionary engineer Richard Yem has created a device that may be able to capture some of this power.
Turning to the world, I think we can say that effectively the opportunity is unlimited. 70% of the world's surface is covered in oceans, and all oceans generate large waves, and there is power available on any coastline facing those.
The experimental device he's invented has begun to capture the world's imagination. It's called Palamas, after a tropical sea snake. The massive contraption stretches 120 meters, longer than a football field. As it bobs up and down in the waves, it converts the wave's power into electricity.
The module itself is, if you like, the engine of the system. It takes the motion of the large tubes and converts it into electricity.
Waves move the giant cylinders, causing hydraulic rams inside to pump back and forth. The ram's motion forces high-pressure fluid to flow through a hydraulic motor, which in turn drives an electrical generator, producing electricity. In total, the Palamas can generate 750 kilowatts of power, over 20 times as much as Verdant's East River turbine, or about 2/3 as much as Seagen. Of all the green power ideas, Palamas may potentially have the widest application. Coastal sites could have massive farms of these machines, generating electricity. The Palamas design took 5 years to develop. Tank tests with wave simulators determined how the machine would perform in all kinds of weather conditions.
The data is fitting very well into this Bible analysis.
From long wave swells to short, choppy ones.
That's great.
Later, scale models were tested in the open water to measure the machine's potential electrical output and to determine survivability. Now, the first full-scale Palamas prototype is nearing the end of a crucial test phase in turbulent seas off Scotland. Its inventor, Richard Yem, has to prove not only that it can generate electricity, it must also be able to take a pounding.
The Palamas is unique in that it combines features which are very survivable. It's long and thin, so when big waves come through, it's streamlined, presents the minimal area to these ocean monsters in storms. But it's that same long, thin form that in small waves is the optimum hydrodynamic shape for capturing power.
Someday, Yem envisions whole farms of Palamas units set just beyond the view of beaches.
The kind of format that we would expect would be an array of machines sharing mooring points between themselves to create a grid of perhaps 30, 50, 100 machines covering a couple of square miles of sea surface.
That's roughly enough to light up a small city like Stirling, Scotland. To get to that point, Yem and his colleagues have their work cut out for them.